Hello everybody, I will start my today with another coding practice. So this video is actually a follow-up of my previous video. So in my previous video, I solved this question, longest palindromic subsequence. And in this question, I'm giving string s and finds the longest palindromic subsequence's length. So I will return the maximum length. But as a follow-up, I decided to solve the question and update the implementation so that I find the longest palindromic subsequence string. Not just lengths, maximum lengths, but I will try to find the longest string. So that's the update I will make in this question. Yep. So that being said, let me get started. So in this question, in my previous video, I solved this question with two approaches. The first one was using the top-down dynamic programming, and the second one was to use bottom-up dynamic programming. And in this video, I will make an update on each of the methods I implemented. And let me firstly say, if I implement that, for top-down DP, I will implement so that the time complexity is n cubed. Actually, it's degraded from n squared to n cubed, but please forgive me for this. And for the bottom-up DP approach, I will update the code which still works in n squared time complexity. And the implementation, for the implementation perspective, this one should be also a bit challenging compared with top-down DP. Please look forward to it. So that being said, I will get started. So for top-down DP, this is my last implementation. So basically, I use the recursion with the memorization. And yeah, for that recursion, the base case is when the remaining string I'm looking at is length 1 or 2. And otherwise, I recursively call the inner string and see the max length of the inner string aside from 2 characters, surrounding characters. And based on that result, I calculate the max length in the current range, then I return it. Okay. So that being said, I will start the implementation. So because I return not max length, but longest one, I will name it longest. Then, let me make it a bit more clear. Okay. Then what I should do is quite simple. I just have to update so that I return the string instead of the length, which is integer. However, one thing I try to take care is that this part in line 31. Here, I have to concatenate the first character, leftmost character and longest palindrome of the inner string, and also with the rightmost character to create a new character. And creating that new character takes all of n time, linear time. So that's why the time complexity is degraded to n cubed. Yeah. So the recursive function is called n squared time, which is exactly the number of combinations of left and right pointers. And yeah, for each, it will take all of n time. So in total, it should take n cubed time. Yep. But as I said, I will make a bit of a compromise for that, and I will go with that. Okay, so now what I will do is just update the method so that it returns a string in terms of the length. Okay. And here, and then line 34 and 35. I will compare the ranks and return the longest one. Yeah, this is it. Okay, so this is the basic implementation, and this is it. And just to check, I mean, just for the check, I still return the maximum ranks. After pointing it. So that I can confirm that, you know, my implementation hasn't led to the wrong, answer. I submit my code. Hmm. Can concatenate the string, not tuple. It's like tuple is returned somehow. Why is it? Ah, here. Okay. And I will submit my code. Good, accepted. So I will quickly check the printed out subsequence is palindrome. Yes. And yes. Okay, good. So now I will work on the bottom up deep implementation. I will try to update this. Okay. So let me quickly explain what doing in the current implementation. So in the current implementation, I initiate the 2D DP table, and each cell represent each substring in the given string S. And I try to fill in the cell with the maximum palindrome subsequence length for each positions string. Yeah. So basically, this 2D DP table is filled in with the maximum palindrome subsequence. So in the end, what I should return was to return the maximum number in this table. However, now I have to return the maximum rank, not the maximum ranks, but longest subsequence. I have to think of the way. So let me quickly again think of this example again. Like this. So firstly, what I did is fill in this table. Like this. So firstly, I filled in with X, which is for invalid strings, and 1 for base case, whose, string ranks is exactly 1. And if the string ranks is 2, I will check if start and end character is the same. If it is true, it should be 2. But otherwise, the longest one should be ranks 1. I will fill this in. Sorry. And now it becomes interesting from here. With this B and B is the same. I will take a look at this one, and 1 plus 2 is 3. And for here, A is not C, so I will take the longest one from this and this, 1 and 1, which is 1. Then here, I will, I mean, B is not C, so I get the maximum of 3 and 1 in here, which will be 3. So this is it. And I return 3. Oh wait, I actually noticed that I actually don't need max ranks in the previous implementation. All I just have to do is return the 0 to n minus 1. Because it is guaranteed that this is the longest one, actually. Yeah, but I mean, I should just return this one in, yeah, my previous implementation. But it doesn't matter. Okay. So my task from here is try to find the longest subsequence, which is a palindrome from these numbers. So basically what I would do is I will try to traverse, the string again. So let's just remember what I did. So here, when B, A, B, C, what I did is compare this string, leftmost character B and rightmost character C. And if they're the same, they should be chosen, as I did. But if not, I will choose ABC, which is without leftmost character, or BAB, which is without rightmost character. And the problem here is that I don't know which I chose, for the longest subsequence. And to know that, I actually have to take a look at the DB table. So I will write the thought process. And I can say from the table, so BAB is index, 1 to 3. So the maximum ranks in this range should be 1, 2, 3. No, wait, BAB is 0 to 2. So by looking at the table, longest subsequence in BAB is 3 versus ABC, which is 1 to 3. So now when I take a look at position 1, 3, it is 1. So this is 1. So from the table, DB table I filled in, now I know that if I take BAB, the longest palindrome subsequence inside of it is BA, length 3. But if I take ABC, then the maximum length of that would be 1. So definitely, I have to take BAB. And as I said, sorry, I haven't said, but if the ranks of them are the same, it doesn't matter which I choose. Yeah. Either way, I can find the palindrome subsequence whose ranks is equal. So I can choose any of 2. And here I choose 0 to 2. And now I find that when I take a look at range 0 to 2, B, which is 0, is equal to B, which is at index 2. So I choose B and B. Yep. Then now the remaining is A only. So I choose A. Okay. So obviously this is the edge case. No, base case. So if length is 1 or 2, I can choose max length by itself. I don't have to go back. I mean, yeah. So if the length of the string is 1, like x, then the longest palindrome subsequence is x. If the string is AB, it should be A or B. It doesn't matter which I take. Yeah. Okay. So that being said, let me start the implementation. Okay, so what I should do is firstly, left and right should be n minus 1. And what I will have to do is I keep doing until I meet some condition. And the condition what I'm telling is left is right case, or, right is left plus 1 case. So in this case, wait. Okay. I will do something. And also in this case, I will do something. This is also the base case. Aside from that, if left motor and right motor is the same, I will choose both of them. And otherwise, I have to take a look at DB table. Okay. That being said, I will prepare the list which stores every character I've seen and chosen. Like this. So I actually need only first half chosen. This is enough. But for the, simplicity and comprehensibility, I prepare 2 arrays. So this should always be the, reverse way, like this. Oh no, like this. And I use Q here because I push from left. And here I push from right. Okay. So if left is equal to right, I just append the left card here, and I end. I don't have to push it in the last half chosen because there's only one character. Wait a minute. Okay. And in this case, there are two cases. If left character is equal to right character, then I have to append it to both of them. Yep. Otherwise, I just have to append the one character to first half. Actually, it works if I append right character to first half. But yeah, it is fine. Now I will think of this case. If this is, oh, yeah, true. I pick S left, which is equal to S right. So I will append it to the, first half and rather half. Then I move the left pointer and right pointer. Because I've already checked if left position character should be used or not. And also same for the right index character too. Otherwise, if I choose I will take a look at two cases. Like this. So I will define the boolean. I will name this boolean a variable name. So for the readability, so this is the case left is kept, and this is the case when right is kept. I should skip left if that leads to the longer subsequence. This is a condition. Now I can do it in this way. Okay. What I should do is I will append, first half and rather half, and I will return the concatenated string. I hope this works, like adding, list and queue. If it doesn't work, I will think later. Yeah, this is it. Okay, so let me execute my code. But before that, let me quickly check my code. So I start from left 0 and right in -1, and I will narrow down the scope while appending the choose which should be chosen to first half and the other half. And while there is still remaining character, I will check it. If left chair is equal to right chair, it should be definitely used. Yep. And if left plus 1 is equal to right, which means that there are two characters, if both of them are the same, I should choose each of them. If not, I will choose either of them. So I choose S left. And in line 128, this is the case when left character is equal to rightmost character. In that case, I should choose both of them. And the range I will take a look would be narrowed down from both sides. And otherwise, S left is not, I mean, leftmost character is not rightmost character. And the problem is which character I should skip for now. So I compress the ranks of the result by skipping each of leftmost character and rightmost character. Then if I should skip left, yep, oh, yeah, I just, increment move the left pointer. Otherwise, I move the right pointer. I don't choose any character in this step. Okay, so this is it. Just to check it, let me print it out. Then I will return the ranks of it. Oh. Memory limit exceeded. Why is it? Probably because of the infinite loop. Oh, yes. Because I have to break here. And also I have to break here. Okay. Let me quickly update my implementation. No, sorry. This is good. Oh, and seems like I cannot concatenate first half and the other half. So let me convert the queue into the list. Good. So it seems like the ranks of the longest palindrome is correct. And also here in line 148, the longest palindrome is printed out. Yes, they are longest and also palindrome. Great. Okay, so let me quickly wrap up on today's coding practice. So this video is a follow-up video of my last video about longest palindromic subsequence. In my last video, I found the maximum length of the subsequence, which is palindrome. But in this follow-up video, I find the longest palindrome subsequence string. And I use two approaches. One is top-down DP, and also the other is bottom-up DP. And in the top-down DP approach, I compromised that, and now the time compressor become n cubed. But in bottom-up DP approach, still the time compressor is n squared. And how did I do that? So firstly, as I did before, I, initiated the 2D table. And after that, I mean, that 2D table, DB table, should store the maximum palindrome subsequence length for each substring. And from that, I traverse the given string again in a similar way. But if I wonder if, I should skip rightmost character or rightmost character, I reference the DB table, and now I know that in the future, which gives me the longer palindrome. So I choose that way. Yep, so this is it. Okay, so with that being said, I finished my today's coding practice. Thank you so much. Bye.